This is MSJ Chem. In this video, I'll be looking at mole fraction and mole percent. Mole fraction is the amount in moles of one component in a mixture divided by the total amount in moles of all components in the mixture. Here we have the equation for mole fraction. From the equation, we can see that the mole fraction of a component of a mixture is equal to the amount in moles of that component divided by the total amount in moles of all components in the mixture. The mole percent is the mole fraction multiplied by 100. So next we look at an example. A mixture of gases at STP consists of 250 cubic centimeters of nitrogen and 50 cubic centimeters of hydrogen. Determine the mole fraction and mole percent of each gas in the mixture. The first step is to calculate the amount in moles of nitrogen. To do this, we divide the volume of nitrogen in cubic decimeters by the molar volume of a gas, also in cubic decimeters. And this gives us 0.0110 moles. Next, we find the total amount in moles in the mixture. The total volume is 0.3 cubic decimeters, which we divide by the molar volume of a gas, also in cubic decimeters. And this gives us 0.0132 moles. So the mole fraction of nitrogen is the amount in moles of nitrogen divided by the total amount in moles of the mixture, which gives us a mole fraction of 0.833. To calculate the mole percent, we multiply the mole fraction by 100, which gives us 83.3%. So next we'll calculate the mole fraction of hydrogen. The first step is to calculate the amount in moles of hydrogen. To do this, we divide the volume in cubic decimeters by the molar volume of a gas in cubic decimeters, which gives us 2.20 times 10 to the negative 3 moles. So to calculate the mole fraction, we divide the amount in moles of hydrogen by the total amount in moles of the mixture, which gives us a mole fraction of 0.167 and a mole percent of 16.7%. Next we look at a quicker way of solving the problem. Because the mixture of gases is at a constant temperature and pressure, we can treat the molar ratios as volume ratios. To calculate the mole fraction of nitrogen, we divide the volume of nitrogen by the total volume of the mixture, which gives us the same answer as before, which is 0.833, and a mole percent of 83.3%. To calculate the mole fraction of hydrogen, we divide the volume of hydrogen by the total volume of the mixture, which gives us the same answer as before, which is 0.167, and a mole percent of 16.7%. Note that the sum of the mole fractions must be equal to 1, and the sum of the mole percents must be equal to 100%. Next, we look at one more example, this time involving an aqueous solution. 10 grams of sodium chloride is dissolved in 50 grams of water. Determine the mole fraction and mole percent of each component of the solution. So the first step is to calculate the amount in moles of sodium chloride. To do this, we divide the mass by the molar mass, which gives us 0.171 moles. Next, we'll calculate the amount in moles of water. So when we divide the mass of water by its molar mass, we get 2.77 moles. We can then calculate the total number of moles in the solution. So that's 2.77 plus 0.171, which equals 2.94 moles. To calculate the mole fraction of sodium chloride, we divide the amount in moles of sodium chloride by the total amount in moles of the solution, which gives us a mole fraction of 0.058 and a mole percent of 5.8%. To calculate the mole fraction of the water, we divide the amount in moles of water by the total amount in moles of the solution, which gives us a mole fraction of 0.942 and a mole percent of 94.2%.